Hello. In this video I will explain how to get started with some of the mapping facilities of the Census2016.geohive.ie website. Census2016.geohive.ie is a site within the GeoHive platform provided by OSI. GeoHive makes authoritative spatial data from public sector bodies available for use with OSI high-resolution base mapping. If you haven't already checked out GeoHive, you can do so at www.geohive.ie or by following the link on the Census2016.geohive.ie website. I'm going to start by once again selecting a theme from the theme gallery to access the catalogue of data for that particular theme. Once again, we see the map and the set of 34 results. This time I want to explore the tags on the left-hand side. If we take a look at the tags, we can see that the Census 2016 themes are mapped at a number of different spatial resolutions, or what we call geographies. These include administrative county, electoral division, NUTS 3 and small areas, and we will be adding further geographies as time progresses. These geographies are suitable for visualization at different scales. For example, administrative counties could be used at small scales, and small areas could be used at large scales to show more detail. To get mapping, I'm going to once again choose permanent private households by year built by administrative county. You'll see that the map updates to show me the boundaries of the administrative counties. At this stage, there's no colour theme applied, they're all just blue and white. Once I go to my variable card and pick a particular variable, once again I get the chart, and now the map has applied a graduated colour scheme to the counties depending on how many, in this case, persons there were living in households built between 1971 and 1980. This is called a thematic map, and the colours are chosen based on smart mapping technology to show areas with high concentrations in darker colours and areas with light concentrations in lighter colours. Administrative county is a useful reporting geography, and many official statistics are only collected at this resolution. However, it doesn't give us a very granular view, so it's not suitable for analysis in any great detail. In order to do that, I'm going to switch geographies and look at the same variable at electoral district level, which I know is on page 3 of my result set. Here you can see the boundaries are much more granular, and we're looking at a much finer level of detail at a larger scale. Again, I'm going to pick the same variable, number of persons in houses built between 1971 and 1980. And now you can see that the map has much more granular, low-level detail. We can zoom in on the map, and our thematic map redraws to allow us to investigate the data in much more detail. In fact, in this instance, you can see a pattern here with a lot of houses built in the 1970s in the ring around the Dublin suburbs. That sort of detail was obscured when we were looking just at administrative county level. At this scale, and using electoral divisions, it's easy to see the power of fusing geography and statistics, as patterns like this become discernible to the human eye. However, it is also possible to go to even finer levels of resolution and look at even more detail. In this case, I'm going to go back and look at the same variable at the resolution of small areas. So small areas are the smallest reporting geography within the Irish statistical system, and they're the lowest level at which data from the census is produced. There are about 18,000 small areas covering the whole country, and each has in the order of 100 to 130 properties, and they've been carefully designed to preserve anonymity whilst also providing detail for analysis. So again, I'm zooming in on Dublin, and you can see the fine-grained nature of these boundaries. And again, once we apply our smart mapping, you can see even more detail in the patterns. Now, one thing I want to point out about this geography of small areas is that because there are so many of them, the system can sometimes have difficulty in rendering the information within your browser. So as I zoom out, what you will find is that you start to get dropout of boundaries once you get beyond a certain scale. This is because the browser is trying to drink from a fire hose of data, and it simply can't render that amount of data in this mode. If you encounter this, one of the ways that you can mitigate this problem is by using the Create Web Map link to go directly into ArcGIS Online and render the data in a more powerful way. Here you can see we're applying a different type of rendering to the data based on a chart showing the number of persons in each small area living in houses built between 1971 and 1980. And we have various options here as to how we apply our charting and which variable we pick. We can also switch back to the thematic rendering if we wish to see that as we did on the census site. Now in this case, the rendering is based, as I said, on the actual number of persons living in houses built between 1971 and 1980. So it's a raw number. The higher the number, the darker the area. And we see various patterns emerging here. But it's difficult to tell in this case whether we're seeing dark areas, i.e. the number is higher, just because the area itself is bigger, or because there's a greater concentration of persons built in houses built between 1971 and 1980 in that area. So what we want to do here is we want to normalize the data, or divide it by a standard variable. So in each of the themes that we've created for the census, we've provided a set of standard variables. In this case, I'm going to pick the total number of persons. And now we get a truer picture where we're normalizing the data by the total number of persons. And you can see that in fact in this case those spatial patterns still persist. Once we have our variable appropriately normalized, we can start to look in more detail and do more analysis on the data. For example, here we're using a theme to show the data from high to low. We could pick a different rendering and show values, let's say above and below, to get a different rendering. In this case, we're showing values above and below the average. We can pick our handles and move them to highlight data in a particular range, and you can see the map rendering changes. Another useful rendering is the centered on rendering. Again, we can pick our handles and change any of the aspects of how the data is being rendered to emphasize a particular point that we're trying to get across, or examine a particular phenomenon that we're seeing in the data. And click OK to save that rendering, and done to go back to our table of contents. So in this example, I have discovered a variable around permanent private households on the census site. I've visualized that on the census site and then gone into ArcGIS via the Create Web Map link to do more analysis and visualization on my data. And finally, what I want to do is save that work. Now I'm logged in here. As you can see, it has my name on the top, and we'll discuss in a later video about how you can get an account and how you can log into the system. But in this case, what I want to do to finish the video is to save my map. So I fill in some basic metadata about the map and click Save Map to save it. Thank you for your time.